Hello everyone, welcome back to Code Compass. Today we are going to solve jump game problem from Leetcode top interview 150 list. So without wasting any time, let's directly jump to the problem statement. So it says you are given an integer array numbers. You are initially positioned at the array's first index and each element in the array represents your maximum jump length at each position. Return true if you can reach the last index or false otherwise. So basically they have given us an array. We are standing at the very first position, which is index number 0. So in this case that will be the value 2, and at each index we are allowed to make jumps, and the maximum jump I can take is equal to the value of that particular position. So from over here I will be able to reach 3 and 1, and they want us to know by making all these jumps across the array if we are able to reach the last position or not. If we can reach it, they want us to return true. If not, they want us to return false. So it's very simple. So for example, over here from the explanation, if we jump one step from index 0 to 1, so they are saying from 2 I can jump to position number index number 1, which contains the value 3, and then I can jump 3 steps to the last index. So from over here I can jump 3 positions, 1, 2 and 3, and I will reach 4, which is what we wanted. So in this case we will return true. But if we check the second example, it has 3, 2, 1 and 0. So let's say you start at this position, 0th index. From over here the maximum position I can reach will be this one, which is 0. But let's say you don't directly jump to 0. Let's say you decide to jump only one position. So you land up at index number 1, which is position 0, but from there also the maximum position which you can reach will again be this 0 only. But let's say you decide that I will not jump 2 positions from these first index, I will only jump 1 position and land over here. But from over there also you can only jump 1 position and you will again land at 0. But as soon as you land at 0, there is no way for you to reach the last index. So no matter what permutation combination you apply, you can never reach the last index. So in this case they want us to return false. So it's a pretty interesting problem. Gives yourself few minutes, try to think it over, and then we will go to the intuition for this problem. Alright, so now let's try to understand the intuition behind this problem. So I'm taken both the examples and we will check both of them one by one. So the first example was 2, 3, 1, 1 and 4. Let me put the index values also, 0, 1, 2, 3, 4. So now as per the problem, our starting position is index number 0, and the maximum jump I can take is whatever value is present at that index. So from 0 I can either the maximum positions that I can reach are indices 0 or 1 or 2. So basically 0 plus 2. So this is the farthest index that I can reach from the position 0. Okay, so let's now go to the first index. Now when I am at first index over here, the farthest position I will be able to reach will be 1 plus 3, which is 4. So from over here, if I was at index number 1, I can reach 1, which is that position itself, then I can reach 2, I can reach 3 and I can reach 4. Similarly for the next index, index number 2, I can reach index number 2 or 2 plus 1, which is 3. So these are the only positions which are reachable. So similarly for index number 3, so these are the indices considered if I am starting from this particular position. This will all make sense, just hold on for a minute. So at index number 3, which is this one, we can either reach index number 3 or 3 plus 1, 4. And finally, if I am at the last index, we don't need to calculate anything because that is our target position itself. So now if you see at each index, if I am able to calculate the farthest position which is reachable, and if any of that position aligns with my target value, then it means that the last position is overall reachable. So but to understand that, basically we will need to keep updating these farthest reachable positions at every step. So what I will do, listen to this carefully, I am going to introduce a variable. I will call it as max reach. So max reach will be initialized with 0. It will be initialized with 0, and it basically tells you what is the farthest possible position which is currently reachable by me. So at index number 0, we will initialize it with 0, and at every step for each I, what I'm going to do is basically I will try to update my maximum reach. So my maximum reach at each position can either be, it will be maximum of max reach, or wherever is the last position reachable from current index, which will be I plus numbers of I. Look at this very carefully. This is the whole crux of this problem. So basically I have a variable max reach which tells me which is my overall farthest reachable position at the current moment, and at each index I am going to update it with the next farthest reachable position, and that will obviously be maximum of these two items. So at each index, let's say you reach some random index over here. There you will try to update your max reach so that it always contains the largest position which is reachable from this particular position. And after that, if once we traverse the whole array and if we end up reaching the last index, it means the last index was also reachable. But let's say you reach a point where your current position goes beyond the max reach, which means you have entered such a particular index which itself was not reachable, and if that happens, it means I can never reach the last position. So in that case we will return false, otherwise at the end of the entire traversal we will return true. So this will become more clear once we see it happening in the dry run. So let me show you what happens and how these variables are getting updated at each position. So let me put these numbers. I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, and I is equal to 4. Alright, so before the dry run, let us write the entire pseudocode what we will be following. So that will be basically we will traverse the array for I is equal to 0 to n. What I am going to do at every position, I am going to check if I have gone beyond the max reach. If this happens, it means we have reached an index which was not even reachable. If that happens, we will simply return false and our entire logic stops. If that is not the case, I will update max reach for the next iteration. So it will be maximum of max reach, comma, I plus numbers of I. And this will keep happening for all positions, and ultimately if we come out of the loop, then we are going to return true. As simple as that. So now let's see what happens with using this pseudocode. Let's try to do a dry run for this particular example. So at I is equal to 0, max reach has been initialized with 0. So now 0 is 0 greater than 0? No. So it means 0 is reachable, obviously, because it is the starting point. So it is always reachable. So now what we will do, we will update max reach as maximum of 0, comma, I plus numbers of I, or numbers of I is 2. So it will be maximum of 0, comma, 0 plus 2, which will be 2. At now, let's come to the next index. At I is equal to 1, numbers of I is 3. So now again check this condition. Is 1 greater than 2? No, obviously not. So which means first index is still reachable. Now we will update max reach, which will be maximum of previous value, which is 2, comma, I plus numbers of I. So I is 1, numbers of I is 3. So now max reach becomes 4. Now let's come to I is equal to 2, which is this position. 2 is not greater than 4. So it means position number 2 is still reachable. It is within our range. So now I is equal to 2, the value is 1. So now max reach becomes maximum of previous value, which is 4, or addition of these two, 1 plus 2. So the maximum is 4. At I is equal to 3, value is 1. Now 1 is greater than 4? No, this is false, which means this index is also reachable. This is within our reach. So now I will again update max reach. It will become maximum of 4, comma, numbers of I plus I, which is 1 plus 3. So it will remain as 4. Now at I is equal to 4, the value is 4. But we no longer need to do this calculation because this is the index which was our target value. So it means that after if I start traversing from the very first position, I will be able to reach the last index which contains the value 4. Now let's see what happens with this example, because over here we will see how this logic works and how we will reach a position which is not actually reachable. Okay, so let's do this. Let's write, let's do a dry run for this one also. So now at I is equal to 0, I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. Let me put the indices over here also, 0, 1, 2, 3, 4. Similarly, max reach will be initialized with 0. And let me put this values, numbers of I and max reach. Cool. So now at I is equal to 0, max reach is 0. So 0 is not greater than 0, which means this will be first position is reachable, obviously. So the value of numbers of I is 3. So max reach becomes maximum of 0, which was the previous value, comma 3 plus 0. So this becomes 3. So max reach right now is 3. At I is equal to 1, value is 2. At value 2, 1 is greater than 3? No, 1 is not greater than 3, which means first index is still reachable. So max reach will become maximum of previous value, which is 3, and 2 plus 1. So this will remain as 3. Cool, so far so good. At I is equal to 2, value is 1, 2 is greater than 3, max reach? No, 2 is not greater than 3, which means this position is also reachable. So our max reach gets updated as maximum of previous value, which is 3, comma 1 plus 2, numbers of I plus I. So max reach becomes 3. Max reach is still 3 so far. Now at I is equal to 3, value is 0. So is 3 greater than 3? No, 3 is not greater than 3, which means this index is also reachable. So now we will update max reach again. Now things will become much more clear. So now max reach gets updated as 3, which is the previous value, and the current value, which is 0 plus 3. So max reach still remains 3. It is still stuck at 3. Now we reach an index which is I is equal to 4. So at I is equal to 4, this condition hits. So 4 is greater than 3. Yes, 4 is greater than 3. We have reached such an index which is not reachable at all from any of the previous positions. So as soon as this condition hits, we will end up returning false, and ultimately we will conclude that we cannot reach the last index no matter what. So just take a few minutes and check both of these dry runs once again, and then you will properly understand the intuition behind this problem. And once you understand that, we will go to the code for it. Alright, so now that you understand the intuition behind this problem, let's try to see how it will look like in the code. So from the beginning, I will initialize our max reach variable from 0. In the end, I will return true, because if we cannot reach the last position, we will be able to determine it before reaching the end of this function. So what I will do, I will start from the 0th position. I will go till the last element and try to recall what we were doing at each step. So at each position, I will basically first ensure if my current position is even reachable or not. So what will determine that? If current position, which is I, at any point of time becomes greater than my max reach. So my max reach is the farthest reachable position at any point of time. If my current position, current index goes beyond that, it means I have reached a position which is just not reachable. So in that case, I will return false and my iteration will stop. But if let's say my current position is reachable, then I will update the max reach as the maximum of max reach, comma, what will be the other option? I can start from current index and I can take a maximum jump of numbers of I. So as simple as that. So let's see if this one works or not. Alright, so our base test cases are passing. For first one, we have returned true. For second one, we have returned false. So let's see if our complete summation also works. Great. So all our test cases are passing. So I hope you understood the intuition and the code for this problem. If you like the content, please subscribe to the channel and we'll see you in the next one.